So in these problems, we want to graph an exponential function that has e as the base, so it's e to the x. So if we look at this function, it's 2 times e to the x, or e to the negative 0.5x plus 3 minus 4. I'm going to write the general form above it, which is a, so that's going to be the 2. The general form is a times e to the r times x minus h. So r times x minus h is the whole exponent, and then plus k. K is a number by itself, or just added or subtracted by itself. So in this equation, a is 2, the r is negative 0.5, the h value, putting negative 3, because in the general form it's a minus h, but there's a positive 3 there. I'm going to put negative 3, and that just means that we're going to be shifting to the left 3. And then the k value is negative 4, which means at the end we'll shift down 4. Okay, so the first step for these is to graph e to the rx. Make a little table and graph e to the rx, which is e to the negative 0.5x. Okay, so I made a table. We're going to plug in negative 2, negative 1, 0, 1, and 2, just like our other exponential functions. So I'm going to start with plugging in negative 2 into e to the negative 0.5 times x. X is negative 2. And we just need to round one decimal place. You could put that into the calculator, get about 2.7. And then e to the negative 0.5, x is now negative 1, and that is about 1.7. E to the negative 0.5 times 0 would just be e to the 0. Anything to the 0 power is 1. E to the negative 0.5 times 1, we get about 0.6. And then e to the negative 0.5 times 2, now x is 2, and we get about 0.4. Okay, so I'm going to start graphing those points. So here's negative 2, 2.7, negative 1, 1.7, 0, 1, 1.6, and 2.4. And notice that the values are decreasing, which makes sense. You know if it's going to be exponential decay if the r value is less than 0. So this makes sense that our points are decreasing. If the so our value was negative 0.5, which is less than 0. So it makes sense that it looks like exponential decay. It's decreasing. If the r value was greater than 0, it would be growth. Our values would be increasing. So the second step is to multiply all the outputs by a, the number being multiplied in front of the function, and that is 2. Okay, so I'm just going to do that right in the table. I put multiply the y values by 2. So 2 times 7.2, that's about 5, or that's 5.4. 2 times 1.7, we get 3.4. 2 times 1 is 2. 2 times 0.6 is 1.2. And then 2 times 0.4, we get 0.8. So all of these points are now kind of moved. The multiply by 2 makes them, the y values get higher, they get doubled. And for example, I'm going to start with the negative 2, 2.7, and now it becomes negative 2, 5.4, which is up here. Negative 1, 1.7 now becomes negative 1, 3.4. 0, 1 becomes 0, 2. I'm going to start erasing these old ones. And then 1.6 becomes 1, 1.2. I'm going to erase the old one. And I'm going to go ahead and also erase this last one because we're going to change it to, instead of 1.4, it becomes 1.8. So now our graph is vertically stretched by 2. And then the last step is to shift the graph. And we look at the h and k values. H is negative 3. We're going to shift to the left 3, and k is negative 4. We're going to shift down 4. Okay, so I'm just going to start with the point furthest to the left, the negative 2, 5.4. I'm just going to count that over left 3 and down 4. And it's going to end up right here. I'm going to go ahead and do that with the rest of the points. And there's where they end up. I'm going to erase the old ones. Okay, it's not actually letting me erase the old one. So our final points are the blue points. I'm going to graph the asymptote. It started at the x-axis, but since we shifted down 4, now there's an asymptote at -4. I'm going to connect the points. It goes along the asymptote. And then the final thing I'm going to do is it's asking me to state the domain, range, intercepts, asymptote, and behavior. So the domain is from -infinity to +infinity. The range is, the whole graph is above -4, so from -4 to +infinity. X-intercept for now, we're just estimating. It looks like it's about a little less than -4. I'm going to put -4.2. Y-intercept, we want to plug in 0 into the function. So 2e, I'm going back to the original function, -0.5 times 0 plus 3 minus 4, and we can just type that into the calculator. I get -3.55, and if I look at the graph and look at the y-intercept, it looks like that makes sense, that it looks like it's supposed to be -3.55, so I'm just double checking that that matches the information on the graph. The asymptote is that horizontal line at -4, so I'm at y equals -4, and then I'm going to write out the end behavior. So on the right side, as x approaches +infinity, that means as we go to the right, the function is getting closer to the asymptote on the right side, so approaches -4. And then on the left side, so as x approaches -infinity, as x is going toward the left, the function is going up on the left side, so approaches +infinity.